We live in an ecosystem, especially in our foothills, that fire is a resident. It comes back at different intervals, but it is frankly part of the landscape, and it's got intervals that vary. Some of them naturally, without suppression. So we're just kind of looking back to a time when fire was not suppressed. There was natural ignition causes, and fire just moved around and was dominated by natural features as far as, and phenomena is actually how it moved and did its thing. So we at least we think we have a picture of what those ecosystems looked like and functioned like. And in our case, in these lower elevations, this lower ecotone, this ponderosa pine forest was probably a bit of a mixed fire regime return interval. So fire might have come back fairly frequently in some areas, and we would have a resultant forest that would be mostly grassy, relatively few large, well-spaced trees. We'd also have places, though, that fire did not return all that often, and we'd have relatively dense north-facing slopes typically, and fire would return there as well, but it would probably be a situation where it was a crown fire type, and would probably replace the whole stand, and new forest would regenerate at that time. So there's just kind of a little picture of that ponderosa pine, and as we move up in elevation, like you go up Wrist Canyon, as you get towards Buckhorn, you're in a mixed conifer forest where there's going to be more Douglas fir, there's going to be some lodgepole pine, there's going to be some aspen. The only one standing. The only one standing. How about that? Eh? How about that?
You're forgetting.
So,
John.
oh, John's down there. Yeah, very innovative. Very innovative. So I guess the take home is that fire is a part of the ecosystem, and the fire suppression that has occurred over these many decades has an effect, especially in those places that fire would have naturally occurred a number of times. So when it did not occur, more woody vegetation got established and got going. So especially in that lower ecotone, we've got forests in ponderosa pine primarily that are pretty dense. And then we see some effects that we don't necessarily want to see when we do have fire, and that's real intense fire behavior and even some soil damage and some post-fire effects.
It is a little ironic how with fire comes floods, and it's really hard for all the locals who have been evacuated for 3 or 4 weeks from the High Park fire, and they get back to their land, and 3 days later their monsoon season starts and they need to evacuate again. And I've seen that with so many landowners up there. It's pretty rough, but that's what we have. With wildfires become floods. We have floods. Do y'all know what, like, you hear about in the media, they talk about a 10-year flood, a 10-year rain event. Y'all know what that means? It's like, on any given, a 10-year rain event means that at that particular point, you would expect that rainfall depth to happen once every 10 years. Same thing with a 10-year flood. It's expected to happen at that point in the stream once every 10 years. Now, with wildfire hydrology, we'll get a 10-year rain event, and what's going to come out of that watershed, if it's heavily burned over most of that catchment, we'll see a 100-year or 200-year flood come out of that catchment. So the floods that we see after wildfires are the biggest floods we really typically see. And the reason why we're getting that is because when wildfires come through, it burns all the vegetation. It burns all that ground litter, and without that sponge, the rainfall that happens, most of it just runs off, or before it just be absorbed by the forest. And with all that flooding comes a whole lot of sediment that's also being washed off that landscape, being washed down into the streams, down into the rivers, down into Poudre River, down to the Big Thompson River, and that really impacts our water supply. It impacts our beer production. It's terrible. So these are very real issues that we have associated with the wildfire burns. It's the flooding and all the sediment that comes with it. It just burns up all that ground litter. And say, well, you have the big raindrops coming down during monsoon season. Say it is a fairly large raindrop. It impacts, instead of impacting the upper canopy, the tree canopy, impacting the vegetation, impacting the litter. Instead, it just impacts that soil or what's left of the soil after the fire came through. So the sediment is all mobilized by that impact. And in addition to that, we don't have that ground litter that kind of builds these little dams all over these mountain slopes that slows that water down, allows it to infiltrate. Instead, it just pours down the mountain slopes, causes erosion, causes rills down these mountain slopes, and builds the sediment up in the stream channels, and eventually that'll end up going down the rivers. Fire comes accelerated geomorphic processes, accelerated erosion rates, everything just happening larger scale. It's happening more frequently. It's really quite interesting from a scientific perspective, though it's terrible for the landowners who are impacted by this every single time it rains.
I think at the end of the day, it's really developing some real tangible, realistic expectation of what we expect from this landscape. It's as Boyd and Steve have alluded to, it's dynamic up there. You know, there's a lot of ebb and flow. It's ecology, folks. It's dynamic, and as part of that dynamism is this expectation for what we expect out of this watershed. We have this sort of superficial, static idea about our roads, our infrastructure, our communities that are overlaid on this dynamic landscape. And thinking about clean water, clean air, wildlife habitat, recreation, vistas, the whole gamut of things that ecosystem services that we get to enjoy as Coloradoans, as people in this community, doesn't really always jive really well with what the expectation of the watershed, of what the ecosystem is. And so thinking about clean water, understanding that maybe in all reality, if fire is going to be a, I think I cut off. Hello?
You have to speak up. Pop the breaker.
Hello? Yeah. I had too much gravitas. I'll just keep going and I'll just speak and project as well as I can. At the end of the day, it's just thinking about what we expect in our communities. So there's this whole notion about good fire, bad fire. Can a good fire burn down your house as well as a bad fire can? You bet. You bet. So what is our expectation in a restored landscape is thinking about these are fire-adapted landscapes, fire-adapted ecosystems, and we need to build fire-adapted communities, understanding that those are the risks we take in living in such a place. Everything from our outbuildings, our homes, all the way down to our water supplies, fundamental fabric of life of our existence in this really dynamic and wonderful landscape. So what defines success? Well, for me, I'll tell you at the end of the day, I blew out again. At the end of the day, no. At the end of the day, it's going to be understanding that an ounce of prevention is always going to be better than a pound of cure. And here's an anecdote that I love to use. Everything for the 4 Mile Canyon fire all the way up to our biggest fire until I'll just say to this year was the most expensive one was the Black Forest fire now. These are not gigantic fires by virtue. They are relatively small. So it's the difference of $2,000 an acre in a restoration treatment, or $50,000 when you add up all the costs of property loss, post-fire stabilization, suppression costs into that business. It just makes economic sense.
One of the big differences between the four of us at the table here, besides my stature, is that I work for a nonprofit organization. Well, it is too. And so, this happened actually all last year after the fire. And partially scrambling around for resources actually do work. I see many volunteers in the audience today, and I know you don't have to raise your hand, but I want you all to realize that volunteers give an inordinate amount of time energy and passion to do restoration around Colorado. I also see landowners in the audience today, some who we have worked with and haven't. And one of the great things that I've kind of walked away from this experience with is how this event, the High Park Fire, really brought together this community of volunteers and the community of landowners who live in the area that was burned. These are landowners who lost everything, including the trees on their property. You know, they came back not only to a home missing, but a black forest and black ground. To see the outpouring of volunteer efforts who were raking seed into the ground, laying out wattles to control erosion, spreading tons of mulch on the ground, areas that we could not get other resources to. We couldn't get helicopters in there. Wherever we could, we worked. We had over 800 volunteers so far to this day working in the High Park Fire area, and we're not done. And so one of our mandates as a nonprofit organization was to help implement emergency watershed protection. Wildlands restoration volunteers typically works on, as you can imagine, ecological restoration. When we look at something like post-fire restoration, it's more of a reclamation. We need to get lots of green grasses and roots growing quickly in the ground. We're trying to redevelop not just the vegetation cover, but a healthy soil that Steve alluded to that receives the water better to try to reduce runoff rates, control erosion. So that was our charge. Results have been pretty fantastic. We're working in the black of the black areas. So areas where just yesterday, believe it or not, in the rain, we're up there and we're still not seeing much growing. But where treatments were applied, where volunteers were on the ground, spreading millions of seeds, we're seeing vegetation cover upwards of 34%, even higher, compared to areas that were not treated, where we're seeing maybe 2% cover. So it's a big difference. And again, it's been tremendous, and I just want to thank all the volunteers, and I urge you to please come out. We need lots more hands on the ground to help these private landowners, to help protect our watersheds. I don't have a booth here, so I'm going to say it again, Wildlands Restoration Volunteers. We don't have a booth, but please visit our website and come out, and we'll feed you, and Odell Brewing will donate some beer as well.
Well, when it comes to that black ash that we're seeing in all those banks, that ash being on those banks then, likely not now, isn't necessarily a bad thing. It's questioning whether or not it's going to be mobilized or not. What I was seeing a lot before the floods happened 2 weeks ago was a lot of willows coming in and trying to retain that material in place. I actually saw that ash being to the pooter beneficial in certain ways, because we could actually get better bank vegetation, and associated with that we can help along certain ecological processes. We would be able to, the majority of food that the insects that trout eat actually come from terrestrial insects that are dropping into the stream. With the willows lining those new sediment deposits on those banks, has more opportunity for a drop to happen for the fish to eat. So that can actually be quite beneficial. I was actually, one of the things that I was disheartened about with this flood timing is there wasn't enough time for the willows to come in to actually hold everything into place. Now it just all got washed down to Greeley. So it kind of goes both ways. In certain ways, it's positive from ecological perspective. In some ways, it's negative. I oftentimes see more of the negative issues are a societal issue. The impacts to our infrastructure and cost associated with that. That's actually where the bigger negatives are.
At the end of the day, it fits into what I was discussing earlier, this expectation. What do we expect? What goods and services, ecosystem services, do we expect from the watershed, and for how long? And then what does the landscape look like to meet that expectation? Is it in alignment with what the watershed can provide, or is it sort of this contrived notion of this, well-engineered system that we can control and just turn the knobs and get exactly what we want out of it? I'd hazard to guess that it's the prior. So to go to the point of what defines success, how much work are we going to have to put into the future until the watershed is quote unquote restored, is really a function of well, what are we restoring to? And what is that defined success? Is it the defined success derived from the ecology and what we understand how this dynamic landscape works, or is it really a function of, well, we need X number of acre feet a year out of this watershed, and we're going to do whatever we need to get that? So the point gets to be is we can do anything, better living through chemistry and engineering, to maybe achieve some of those ideas, but at the end of the day, it's really going to be, is it tied to a realistic expectation of what the ecology and the watershed can provide us? And I hazard to guess that being aligned more with the ecology will probably yield a better set of results and meet our expectations instead of this better living through chemistry and engineering.
But you aren't dissing all engineers, are you?
Just those that think that the globe is a perfectly smooth sphere.
Good. I could give that a shot, but I don't know if I have a perfect answer, because the world is not a perfectly round, smooth surface.
Yeah, it's ellipsoid.
So if you can imagine, before the fire burned through a very dense forest, there were many, many decades of leaf litter built up underneath, and the soil beneath that leaf litter was highly receptive to water, and so it was very much like a sponge. Actually, in a lot of these areas, there was not a lot of vegetation growing, and we can see that now. What might have been there was scorched, and there's not much coming back. In some areas, we are seeing things coming back. So we can't really build that soil exactly, but we do know that the faster that vegetation and their roots, more importantly, are sent down in the soil, there's a process there whereby we're fixing carbon from the atmosphere and it's going into the soil. These roots are creating pores in the soil. They're creating a less dense soil. Right now, that soil is very compacted, just from raindrops, from snow, from lack of this organic matter, and it's been burnt. It's been fundamentally altered. And all I could say is it's a long process if there's not a lot of vegetation coming back. And so I don't have a good answer in terms of how much faster it's going to be, but the results that we're seeing when you look at 34% vegetation cover versus 2%, you can imagine that the process is going to be perhaps equally quick. Whether or not that actually is going to benefit the native ecosystems is another question. There are a lot of plants that perhaps could be impacted by this aggressive grass cover that's being grown up there. We're hoping that some of our research might help to elucidate that question, but we do have to look at those trade-offs, and so perhaps doing more aggressive treatments above areas like the Monroe Tunnel to protect water quality. Maybe it's a trade-off where areas that aren't being impacted, we're not impacting downstream infrastructure or water, maybe those areas can be left to natural regeneration. I hope that answers your question.
We'll call it black carbon. It's a really kind of a neat thing. We don't know a lot about it. There's been some research on it at a landscape sort of watershed wildland scale, if you will. One of the properties is it has what's called a high cation exchange capacity, which is a crazy psychobabble science term for it absorbs cations. And one of the cations that's really important in the growth of vegetation is nitrogen. And that binds to this, it has the ability to bind to these plant available nitrogen to these black carbon. The really cool thing about it is that it breaks down over time. And so it can be sort of this pool of carbon that would normally be flushed down or this pool of plant available nitrogen that would be flushed with the rains actually might kind of be held up by this black carbon if it sits there and then released over time. Now, the cool thing is you could have that with a frequent fire return interval where this black carbon is constantly being generated through fire, wildfire, prescribed fire, that it could be this kind of carbon or this nitrogen sink, if you will, that slowly releases nitrogen, which is really cool. It's part of this cool dynamic process. Problem gets to be is what we see with it is that with these big fires and then these big rain events that you have these little chunks of black carbon that just get carried all the way down, through the watershed. But again, we don't know a lot about it. We are dabbling with stuff called biochar and trying to figure out how it could be used effectively to do remediation and stabilization work. But at these large catchment scales, the science is not there.